Hi, everyone. Let's take a look at the following example. Find the integration or find the antiderivative of sine of kx with respect to x where k does not equal to 0. Step 1, when you think about sine of kx, there's a bracket that's understood. So you're taking the sine of, in brackets, kx with respect to x. So if you think about this, the antiderivative of sine should be negative cosine. So again, put the negative at the front. Cosine of kx. And you divide this by the derivative of kx. And when you take the derivative of kx, that's going to be k. And again, you're adding a constant at the end, c, where c is an element of real numbers. So again, be mindful, you're not finding one answer. You're finding infinite many answers, which are collapsing into this family of solutions. Now, how do we know we're doing it right? Well, I would say it's not unreasonable to double check your work by spending 1 extra minute. And by double checking, what you're really doing is you're finding the derivative of the answer. And if we double check correctly, the answer should be exactly the question that we started with. So what I mean is this. If I let y equal to negative 1 divided by k, and you multiply this by cosine of kx plus c, and I take the derivative, I should get the question back. Let's find out. dy by dx equals to, and again, if you think about the constant, negative 1 over k, that is independent of the derivative, so you can leave it as is. When you take the derivative of cosine, that's going to be negative sine of kx in this case, times the derivative of kx, which is k. Let's put a set of brackets to separate them. And look what happens when you clean this up. Negative times negative is positive. K divided by k is going to be 1. And as expected, you get exactly sine of kx back, which was the question we started with. This is how you know you did it right. The power of double checking. I hope this makes sense.